Hello everyone, welcome to this video, which is part of the series of videos on the basic inventory models. We talked about the economic order quantity model and we talked about the production order quantity model. In this model, we'll talk about the quantity discount model. So we go back to the economic order quantity model, where we assume that there were no discounts on based upon quantities, and that's the assumption that we are going to relax in this model. All right. So let's proceed. So reduced prices are often available when larger quantities are purchased. This is something that you would have noticed in real life. And trade-offs, now the trade-off is not just between holding cost and ordering cost. It's actually the difference between the product cost itself, because you're able to buy the product at a lower level, and the increased holding cost, because if you're able to buy the product at a lower level, you might want to stock up larger quantities. So that's the trade-off now. The ordering cost does play a role in it, but not as much as the product cost is. Product cost is order of magnitude higher. Here's an example of a quantity discount schedule. Let's say that they say the initial price is $100 per unit, but if you buy more than 120 items and say less than 1500 items, we'll give it to you for $98. Or if you buy more than 1500 items, every time you place an order, we'll give it to you for $96, right? So let's say that this is an example of a quantity discount schedule. The other way a quantity discount schedule can be offered is, instead of saying that the unit price is 2% or so $98 and $96, they can say that we'll give you a 2% discount if you order between 120 and 1499. I'll give you a 4% discount on the $100, right? So it ends up being the same. It's just a different way of looking at the same thing. So what do you do? How do you go about looking at the quantity discount model? What I'll do is I'll move to an Excel sheet and do some of the calculations there, but let's basically go over how you look at a quantity discount model, and then we'll look at the Excel sheet, right? Okay, so the total cost, remember, it's not just the setup and holding cost, but you're also going to include the product cost itself. And it is, this is the formula. Now, one thing I'll notice is that in the old holding cost formula, we would write Q over 2 times capital H, where capital H is the holding cost per unit per year. But now, because the product cost itself can be different in different scenarios, you write holding cost as a percentage of the price of the item. So you say that if, so in this example that we're looking at, so we say that the unit price varies, the holding cost is expressed as price of a percentage of the price of the unit, right? So I'll come back to this. I'll explain this in more detail when we move to the Excel file, but that's the basic idea there. So the optimal, so the EOQ formula remains the same, 2DS divided by capital H. So remember, capital H is the holding cost per unit per year. That is, if you held one unit in inventory for a whole year, how much would it cost you? That was the capital H holding cost. That was the value that you had here. Now that, instead of being a fixed number, can be expressed as a percentage. So you say that if the unit price, let's say that it costs, I don't know, $100 to buy an item, right? So $100 is the basic cost of the item. Then if you say that your inventory holding cost is 20%, it means that you're spending 20% of the price of the item. Holding it in, if you held it in inventory for a whole year, it would cost you 20% of the price of the item, right? So if $100 is the item, then the holding cost for the whole year will be $20. So if you bought that one unit, kept it in inventory for a whole year, it would cost you $20, right? So that's how you represent it. And the reason why we represent it as a percentage is because when you are looking at a quantity discount schedule, the unit price itself is different. So your holding cost values are also going to be different, right? So keep that in mind. So what are the steps involved? So the first step is we look at each potential options, the regular price, quantity discount 1 and quantity discount 2. We look at each of these options separately and calculate the EOQ formula, right? Now, EOQ formula and see if it is feasible or not. So this is possible for the best order quantity along with the price break quantities and all lower prices. Now calculate the total annual cost for all the different options that you're considering, and then whichever produces the lowest cost is the one that you choose. It's as simple as that, right? So let's implement this. So I'm going to move over to an Excel file where I have these numbers here. So like I said, I forgot to put in the unit price. The unit price is $100, right? Okay. Now, ordering cost is $200. We put dollar signs and annual demand is $52. Okay, good. Now, so we say that the unit price is $100. The first discount was 2% on the $100. The third is the discount of 4% on the $100, right? So we have that. Annual demand is 5,200 and our holding cost percentage is 28%. So 28% of whatever your per unit item is, right? So that's the first thing that we'll calculate. So once you have a discount number, you can calculate unit price. That's the first thing that we are going to calculate. The unit price will just be, well, it has to be $100. That's a basic unit price, right? So $100 times 1 minus the discount. If you have no discount, it'll just be $100, like this is the case, right? Or now it's always going to be $100 times that. So I'm just going to make that an absolute reference. Actually, you don't have to do all of that. Let me just put it this way. So we know it's $100. We'll just say 100 here. Or you can just refer to this cell, and if you're referring to this cell, just make sure that you refer to it as an absolute percentage with dollar signs in it, right? So it's $100. That's the unit price with no discount. With a 2% discount, it will be $98, and with the for 4% discount, it will be it's $96. Right? So these are dollar values. So let me just get rid of that. So that's my unit price. Now, then with my unit price, now I can calculate my holding cost. So this is the holding cost per unit, right? The holding cost per unit will be the unit price times this percentage, the percentage that you had. So it's 28%, right? Holding cost times 28%. So 28% of $100. So if you hold this item in inventory, so this item, let's say it's I think these are hypodermic needles was last example, I forget. So whatever you're selling here. So whatever item you have here, if you're holding that in inventory for a whole year, it costs you $28 if your unit price is $100. But if your unit price is $98, it is going to cost you less. Why? Because, well, it's 28% of whatever your unit price is. That's how much you... Now, why does this make sense? Why does it make sense to have the holding cost as a percentage, right? And we looked at this also. So if you remember, when we talked about the holding cost, we said that we can represent holding cost as a percentage. And the reason why we represent it as a percentage is because there are different things that go into a holding cost. So you can have housing costs, you can have material handling costs, you can have labor costs, any investments that you made, any pilferage or obsolescence costs. All of these costs add up together to give you a holding cost value. So the holding cost is a percentage, right? And different industries have a different percentage of holding cost. So in this example that we are doing, we are assuming that holding cost is 28%. So it can be as low as 15% and almost as high as 40% if obsolescence is a very common thing that you expect to happen. All right. So there you go. So that's why holding costs can be different based upon the unit prices. They are a percentage. So if you're buying the item for a lower item, for a lower cost, then if you're borrowing money to buy the item, you have to borrow less, right? And you have to pay, everything is based off of this unit price. So everything is lower, right? So it's a percentage of that. Here you have that. So once you have the holding cost capital H, now I can calculate the Q star values. Now the first step is Q star. I'm just going to call it Q star before discounts. You know what? I'm not going to call it Q star. I'm just going to call it Q. I'm going to call it Q. This is because we're going to write the formulas. It's square root of 2 times capital D, which is the annual demand, 2 times 5,200, right? Times S, which is the ordering cost. Let's say ordering cost is $200, right? 2 times D times S, 2 times D times S, over capital H. So capital H is the unit holding cost that we calculated. We have that there. So this is going to be different for each of these cases. So I'm going to refer to that in the formula. And that's my value of Q star. Now, that's my value of economic order quantity before you do any changes to it. So before you adjust it. So call it Q star pre-adjustment. What is this pre-adjustment thing? Now, first things first. If you notice that, so for our optimal order quantity, if my optimal order quantity is 272, then I'm automatically going to get a 2% price. So this value of Q star is outside this range. Now, being outside the range by itself is not such a big problem. I'm going to move myself just a little bit. Being outside the range by itself is not such a big problem. But if the value of Q star that you calculated, the value of Q star that you calculated here, pre-adjustment you calculated here, is more than the highest value in the range. It's more than 119, right? 272 is more than 119. So then this option is not feasible anymore. Why? Because the best thing that you can do is outside the range, and it is more than the range, which means that if you do less, it's going to cost you way more, right? So I'm going to say Q star final, call it Q star final. So when you do Q star final, if the value of Q star is more than the highest value in the corresponding range, then you don't have to consider that option. This option is infeasible. This is not going to be the optimal value, right? So because 272 is more than 119. Second, if this number is within the range like it is here, then you keep the number, right? Now I am obviously going to round this. I'm just going to call it round this number. I'm going to round this to 0 decimal places. I'm going to round it up to the closest value. So 275, that's the value of Q star here, 275. Now, but if you look at this number again, 278 is outside this range. So 1500 or more to get the second discounted price, right? So 1500 or more, 278. So, but 278 is outside the range, but 278 is less than the lowest value in the range. And that is okay. If the Q star that you calculated pre-adjustment is less than the lowest value in the range, you can keep it. But for you to receive this discount, you have to order a minimum of 1500. So if this number is outside this range but lower than the smallest number in the range, then you use the smallest number in the range. So this is going to be 1500. Why? Because you're saying, well, my optimal order quantity is 278, but I need to order a minimum of 1500 to receive this discount. So that's how much I'm going to order. But because in this case, I have to order 275 to be at the optimal order quantity, and 275 is within the range, I'm going to keep 275. But let's say that we calculated this number and this number turned out to be, say, 105 or something, right? So if Q star was 105, then it is lower than 120, then you would make this 120, right? So now what we're essentially doing is, now because 272 was more than 119, we don't have to consider it. So I'm going to leave that alone. So now we are considering two options. The two options we're considering is, we will order 275 items every time we place an order at $98 an item. That's the first option. Or we will order 1500 items every time we place an order at $96 per item. And these are the two options that we're going to evaluate. Now, why would this option not automatically be cheaper? We are getting it at a lower price. The reason for that is, remember that you have to order 1500 items every time you place an order, which is way more than the optimal order quantity, which means that you'll be your holding cost is going to balloon. So if your holding cost is going to be really high, it might offset the advantage that you receive by lowering the unit price itself, right? So let's figure that out. So to do that, we'd calculate the total cost. So what I'm going to do is I'm going to make this slightly smaller so I can accommodate a few more columns. So we are going to calculate the annual ordering cost. We'll calculate the annual holding cost. Spell it correctly. And the annual product cost. Right? So 3 costs, then finally the total cost. Right? So those are the 3 costs. 4 costs rather. Oops. Now I'm going to move my head back up to where it was. All right. Let's do that. Okay. I guess I'm going to have to make the font a little bit smaller again. Okay. That is pretty good. All right. So annual ordering cost. So annual ordering cost, remember it's D over Q times S. So D over Q is the number of orders that you place in a year. So capital D is 5,200. Oh, I don't have to do that for the first option, so forget that. It's 5,200 divided by Q. Q is whatever Q star that we calculated. So this is the number of times you'll place an order in a year times the ordering cost, which is $200, right? Holding cost. So this formula, you can copy that down. This is the ordering cost here. So what I'm going to do is I'm going to make all of these numbers dollar values, right? Okay, now let's calculate the annual holding cost. So the annual holding cost in this case, remember, it'll be Q over 2 times capital H. So Q over 2. So it'll be Q over 2. This is the average inventory that you hold times capital H. So capital H is what we calculated here, right? So that's capital H. So that's our holding cost. So now you'll notice that because we are pretty close to the optimal order quantity, the holding cost and ordering cost are close to each other. 3781 and 3773, pretty close to each other, right? So we did go down from, if we use 275.3211, the whole thing by itself, these two numbers would be exactly the same, because that's how you calculate the value of Q star, right? Now let's look at the holding cost in this case. So the holding cost in this case will be again Q over 2. So in this case, Q is 1500. So 1500 over 2 times H, that's my holding cost, right? Way more than the holding cost here, right? So the ordering cost is lower because you're not ordering as many times, but the holding cost is way more than that. So the question is that offset by the product cost? So the product cost is just P times D, right? So P is the unit price times annual demand, which is 5,200, right? So that's the total product cost here, and I'm going to calculate the product cost here also. Now, I want you to notice that always the holding and ordering cost will be way less than the product cost. So any savings you can make in the product cost will have a much larger impact than the other thing. So, but let's see that if this difference offsets this difference. The total cost is the sum of these numbers. I'm just going to say sum, and we can just add these numbers together, which is plus that, right? Okay, 150 point something, and there you go, right? Now, even though the annual product cost is lower here, the total cost is lower for the second option, buying at $98 rather than buying at $96, because you have to order a massive number of items every time you order and pay a massive amount of a holding cost, right? So it doesn't make sense for you to do this. So the decision is finally based upon your total cost values. Whichever total cost value is the lowest, that's the total cost value that you use. All right. So in this case, the total cost value, lowest total cost value is here. That's the value. So what does this mean? So this means that the final value of Q star is 275. You will order 275 items every time you place an order. That's what it means, right? So that's the value of Q star. So what are the number of orders? So number of orders will be annual demand, which was 5,200, divided by the value of Q star, right? So number of orders will be 18.9. So don't round this. This means that you will place 19 orders in a year, but 91% of the final order will be accounted for in this year. The remaining 9% gets accounted for in the next year. So the cycles are slightly off of your annual cycle. That's all that means. So number of orders should never be rounded, right? We'll just keep 2 decimals, but that's fine. That's the number of orders. We know what the total cost is, right? So total cost is right there, 150. We calculated the total cost. And the number of cycles in a year, cycle time. Cycle time is the time between orders. So we'll say that there are 250 days in a year, right? Divided by the number of orders. So the time between orders is 13.22 days, right? That's the time between orders, 13.22 days. So 250 days in a year, and that's that. That's the cycle time. So these are the important values that we calculate. We calculated the annual ordering cost, annual holding cost, annual product cost, total cost, and we decided that this second option is the best option, taking the 92% discount rather than taking the 4% discount, because you have to order a much larger value. Right? And that's the quantity discount model. Right? So I'm going to stop here, and I'll see you all in the next video when the production order quantity model and the quantity discount models are alternatives for the economic order quantity model, but the first part of the economic order quantity model. Remember that there are two parts to the economic order quantity. The first part answers the question, how much should you order? And this is what we answer the question here. Using the first part of the EOQ model, the production order quantity model, or the quantity discount model, we are able to answer the question, how much should we order? In this case, you should order 275 items every time you place an order. But we haven't answered the second question, which is, when should the next order come in? That is the reorder point, right? So we looked at that in the economic order quantity model. We looked at reorder point, and we looked at lead time and all of that. But what if demand is not constant? What if lead time is not constant? What if there's variability in all of this? That's what we will answer in the next few videos. All right. I'll see you all in the next video. Till that time, if you have any questions, feel free to email me, and I'll see you all there. Take care.